Okay, this is about systems of equations for Unit 3. Systems can be nonlinear, so this means that instead of having two lines that connect, they could be some other types of graphs that we might see, like maybe a circle and a parabola, or parabola and a line, an exponential equation and a circle. Just depends. So we can have these types of systems, and we need to know how to solve them. So one of the ways that we can find a solution to systems, even if they are nonlinear, is by graphing it. And when we graph it, we're looking at where the two lines intersect. Now before, when we dealt with systems, they were linear, so they were only intersecting in one spot. But with nonlinear systems, we can have more than one solution because they can cross in a couple different places, or they could have no solution where they don't cross at all, just like we did with the lines. For example, if I had a graph and here is my system, so one of them's a circle and one's a line, notice that they intersect in two spots in this particular case. Another example. This one would have no solution because, as we can see, even though one of them is not linear, they are not going to cross, and so that would be no solution. So one of the things is that we can also determine if something has a solution by looking at an ordered pair and making sure they work in both equations. So, for example, is the point 2, 3 a solution to the system? And the system they give us is x squared plus y squared equals 13, and 2x minus y equals 4. So the way that we would determine if this is a solution is we need to plug this point into both of them for x and for y. So if we plug that into the first one, we would have 2 squared plus 3 squared equals 13, and we're trying to determine if that works. So 2 squared is 4, 3 squared is 9, and 9 plus 4 is 13. So that one works, but we're not done. We definitely have to make sure we plug it into both to see that it does work. So the second one, we would have 2 times 2 minus 3 equals 4. And so 2 times 2 is 4. 4 minus 3 is 1. Does 1 equal 4? No, it does not. So here we would say it is not a solution. Okay, next example, we want to be able to find the solution to the system. And so again, we can use some of the strategies that we used for linear systems, which meant substitution or elimination. Those both will work for these systems. So our system, y equals 3x squared minus 8x minus 2 and 2x minus y equals 5. So let's look at substitution. So I want to take this equation here and rearrange it so that it says y equals. So the first step in doing that is I need to subtract the 2x from both sides. And so I have negative y equals 5 minus 2x. And then I have to get rid of the negative in front of the y. So I'm going to divide everything by a negative 1. So now I have y equals -5 plus 2x. So what I want to do is, now we realize that an equation means that y, in this case, y is the same as all of this. So now in the first equation, anywhere I see y, I'm going to replace it with all of that. So we have y, I'm going to rewrite it, y equals 3x squared minus 8x minus 2, but now we're going to replace the y. So we replace that with the 2x minus 5 equals 3x squared minus 8x minus 2. Now we have a quadratic here, so that means that we will need to move everything over to one side to either be able to factor it or use a quadratic formula, all that good stuff. So we need to subtract 2x from both sides, and we'll need to add 5 to both sides. So we get 0 on one side, we get 3x squared, -8 minus 2 is -10x, -2 plus 5 is a +3. So at this point, let's use the quadratic formula to figure out this solution. So remember, that's -b plus or minus the square root, b squared minus 4ac all over 2a. And in our case, a is 3, b is -10, and c is 3. Alright, so we have -10 becomes +10, plus or minus the square root of -10 squared minus 4 times 3 times 3 all over 2 times 3. And so -10 squared is 100, and then we have 4 times 3 times 3, and that gives us 36. And so now we have 100 minus 36. So we have 10 plus or minus the square root, 100 minus 36, and then we have 2 times 3, which is 6. So now we have 100 minus 36, that gives us 64. So 10 plus or minus the square root of 64 over 6. But the square root of 64 is 8. So we have two answers. We have 10 plus 8 divided by 6, and we have 10 minus 8 divided by 6. And so 10 plus 8 is 18 divided by 6 is 3. 10 minus 8 is 2. 2 divided by 6 reduces to 1/3. So these are our two answers for x. So back up here, remember we're solving for x. So x equals 3 and 1 and also 1/3. So now we have to plug those two numbers back into one of the originals in order to see what y equals. So 3 and also 1/3, and we can plug it into any which one we want. So any of the original. So y equals 2x minus 5. Let's plug those in and see. So over here we have y equals 2 times 3 minus 5. That is 6 minus 5, so y equals 1. So the first answer is 3, 1. Now over to here we have y equals 2 times 1/3 minus 5. This one will take a little bit extra, but 2 times 1/3 is 2/3. And then here you will probably need to do a common denominator to find that answer. but for the sake of time, we get negative 13/3. So on this one, our answer is the point 1/3 negative 13/3. So 2 answers for this one. This means that if we had graphed this, we would see that they would cross in 2 places. Okay, another example. Y equals negative x squared minus x plus 2, and x plus y equals negative 2. So again, probably want to use our substitution, but notice this one's already solved for y. So what I'm going to do is, here's where y is in the other one, I'm going to replace it with all of this. So if I rewrite that second one, I get x plus all of this. Negative x squared minus x plus 2 equals negative 2. So now we want to continue and solve. So I don't really need the parentheses since we're adding, but x plus a negative x is 0. And so we have negative x squared plus 2 equals negative 2. And so we want to subtract 2 from both sides. And so now we have negative x squared equals a negative 4. Whoops. If we divide by a negative 1, we have positive x squared equals a positive 4. And then we have to take the square root of both sides. And remember, when we take the square root, we get 2 answers. So our answer is plus or minus 2. So that's where our 2 answers are going to come from. We have one answer that has 2 something and the other one that has negative 2 something. And so we need to plug these back into either equation. It does not matter which one we pick. So if we do x plus y equals negative 2, we need to plug in 2 for x. So 2 plus y equals negative 2. Subtract 2 from both sides, so y equals negative 4. And then we need to do the same thing with the negative 2. So here we have x plus y equals negative 2, and we plug in a negative 2 there. And so we want to add 2 to both sides, and we get y equals 0. So this solution is negative 2, 0. So these are the 2 answers I'm looking for. Okay, this also works if they are written in function notation. So f of x equals 2x and f of x equals 2 to the x. We can definitely graph them if you want to see that type of solution. So let's take a look at what that might look like. Now with graphing them, you have to be very careful because you're looking for the one, almost like a needle in a haystack, of where they cross. And so my drawing on here might not reflect the correct answer, because you need to really use some measurement type tools. I didn't make that long enough, so let me start over. And make sure you use a straight edge and so forth. Graph paper is always a great idea. So to graph these, you could make a chart. So for the first one, we have f of x equals 2x. You can make an xy chart and have some points to plot. So I could pick -1, 0, 1, and so on and so forth. So if I plug in -1, 2 times -1 is -2. 2 times 0 is 0. 2 times 1 is 2. Same thing with the other equation, 2 to the x. We can make an xy chart and pick numbers so that we can plot them on the graph. So if I plug in -1, 2 to the -1 is 1/2. Remember our rules for exponents. 2 to the 0 power, anything to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4, and so on. And so we want to plot these points on our graph. So our first one, -1, -2 is down here. And then we have the point 0, 0, and the point 1, 2. So this one is a line. And now to graph the other one. So we have the point -1, 1/2. 0, 1, 1, 2, 2, 4, so on. So this one is an exponential, and that's what that looks like. And on our graph we can see that they cross about right here, which is the point 1, 2. Now coincidentally, when we did our chart, we can see that they did in fact match at 1, 2, and so that would be the solution to this. They only cross in one spot, but they definitely do have a solution 1, 2. So that's the end of this recording. Now you need to call, text, or Skype message me so we can talk about this recording and ask you a couple questions, and so you can get credit for the assignment. Have a great day.